Hello everybody and welcome back to MACH 2022. We are on our stand, MTDCNC, and Intoco's stand, Intoco Special Steels and Alloys, and this is what the next 40 minutes pretty much is all going to be about. It's going to be about an education on exactly who Intoco are. So we've got loads to tell you. Gio, ultimately, who are Intoco?
Intoco Special Steels and Alloys are an independent company that supply steels and alloys not just in the UK but around the world. They hold over £18 million worth of stock at any given time, and in a current climate where people are suffering material shortages, that is just phenomenal. They pride themselves on quality, traceability and all the accreditations that you could possibly need, and they colour code their materials, which we'll be touching on shortly.
You've literally just said all my notes,
so
Gio.
As a company, they are a company that you can trust and rely on.
Yeah, absolutely. We've you've said it all, really. But we've done some fantastic videos with Intoco as well, haven't we? We've done a video, so if you want to look it up, on YouTube as well. It's called Do You Really Know What You're Machining? And that's kind of like a serious education. Who Intoco are, you'll see their facility, you'll see what they've got, you'll see the colour, why they're all colour coordinating. In the background here it says the bar menu. And so you've got different materials of different colours. We'll touch on that a little bit later, but ultimately, why is that? Because it's very unique to Intoco, isn't it? It is
extremely unique, Lindsay. And just before I go on to the colours, the video that you actually did with Les Priest on how-to, the how-to video, I'd strongly recommend you get onto the Intoco platform on the MTDCNC website and watch that video. It's had thousands and thousands of views. Absolutely brilliant educational piece. The colour coding is extremely unique to Intoco, and I'll be talking to Douglas Crooks about that at the end of the show, and why it's unique. But it's all about organisation. Yeah. They go to the nth degree to make the life of the consumer easier. They don't need to do that, but they do everything above and beyond for their consumer.
So they've got a lot of stock. They have a lot of value-added services as well. So if you are after these materials, you're talking about bar, billets and plates, all there in different varieties, and that's what was really important to Intoco as well, is adding that value at source.
They're specialists. They don't just supply materials. They are specialists in what they do. They are specialists in materials. They know just about as much as Rowan.
Rowan's going to be looking at some really juicy parts momentarily. He's literally on a stand over the other side of the halls, but I'll never forget when we went to meet Les on one of the first days. He had this whiteboard out and he was explaining to us about materials, and I was just, I don't think I've ever slept so well that night, because my mind was blown about like the education. And I think for me that's important. And I'm not an engineer, but what I know is if I'm cutting a material and I'm making a quality part, you want to make sure that what you're cutting is perfect, that traceability, that reliability, and he's got it all up there, hasn't he?
You spent the whole day with him, didn't you, Lindsay?
I was exhausted by the
whole
end.
day. and today's not just about materials, but it's the applications as well. Yeah. How do you cut these materials? There's also another great video on the MTDCNC platform on how to cut alloy 718, which we did a great case study with Intoco, but today we're basing it on another material, Super Duplex F55. So Rowan's going to be on the Open Mind stand looking at a demo, and I think you could talk us through that, Lindsay, but it's going to be an unbelievable case study that he's going to be reviewing today.
We'll be seeing that momentarily. Now, we've got caps on the stand as well. So during MACH, we've got caps that we're giving away. We've got a competition. You have to guess the weight of, you'll see the part in a few moments' time. You have to guess the weight in kg and you win that in cash. There's loads going on. We've got the magazines. So in our MTDCNC magazines, you've got all of what they provide as well. So have a little look at that. So that's the the MACH show edition, and we've also got the Swarf and Chips paper as well, just showcasing everything. It's a nice menu. There was something else I wanted to mention as well. Yes, follow them on LinkedIn, because if you scroll down, you can see that they've had flash sales on and everything like that. So just follow Intoco and you'll get a great education there. So anyway, let's head over now to Rowan. Is there anything you want to add before we see Rowan?
Yeah, well, Rowan's going to kind of highlight something very special. He's going to be looking at CAM strategies to cut Super Duplex F55.
And Joe's actually with ZCC as well, isn't
and then
he?
when we come back, we're going to be looking at the cutting strategies to cut the same material. So we're going to be looking at cam strategies, cutting strategies. So it's not just about the materials, but how to cut their materials, because there's so many ways to skin a cat. Yeah. We want to know Rowan's way, or shall I say Open Mind's way, and then we want to find out how David from ZCC would cut his the material, because there's lots of different strategies that you can use, but we want to find out the very best strategy, because it's all about being more efficient and more productive. That's what this show's about, saving money and becoming successful.
How many cats do you skin, Gio?
I'd skin as many as I possibly can.
Right, over to you, Rowan, at Open Mind.
It's great to be here on the Hypermill stand on behalf of Intoco, who obviously provide a lot of different stainless steels and tool steels. They offer a lot of tool steels like this, but they also offer F55 super duplexes, which unfortunately this is not. This is a hardened tool steel. But what are the challenges with machining such a beautiful part like this in such a hard material?
Okay, so yeah, we're instantly looking at areas where we need perfect blending, super high quality and efficient material removal. Being hard materials, that tool life, you need it to last. You're getting tool breakages halfway through the cut. We can't be dealing with that. So, we've got a number of optimized, cycles and strategies designed for cutting these harder to cut materials.
Let's imagine this was a blank billet right now, and you knew what you had to get out of it. Yeah. But you've got to start with the roughing. Now that's going to be a massive amount of material to take out, which is all going to be really hard. You've got a lot of abrasive wear on the tools. How do you minimise the tool wear, maximise your tool life, while also reducing the cycle times and making a good part in as short a time as possible?
For sure. So there's a whole host of bulk material removal here. So ideally for that, we're looking at the optimised roughing strategy in partnership with the high feed cutting tools, these indexables. Our optimized roughing, it focuses on straight line movement cutting and keeping engagement in the material. So we know there's challenges of when you're exiting and entering the material, get these hot spots and these almost work hardening of the material. The strategy is designed to maintain cut, so you get heat evacuation in the chip, and straight line movement, which helps you to maintain feed rate, so you get the quick.
Yeah, so there's a lot to think about, Josh, when you're machining a part like this. I mean, look at this. You've got loads of little pockets. You've got loads of tiny little deep kind of half bores and whatnot. And it must be an absolute nightmare to try and rough this, because you'll end up with loads of, if you're taking like a deep 25mm, 30mm deep cut, and let's say you're doing a trochoidal path, you're leaving loads of big steps that you then got to take out again. So it's all about managing the difference between the roughing and the semi-finishing passes and whatnot.
Yeah, absolutely, Rowan. So when we're starting to move in toward the cavity type areas, you probably move away from the high feed style machining with the indexables and move toward your end mill and adopt the trochoidal style cut. That's helping to again keep the heat evacuation in the chip, high feed, longer tool life, and you're able to get into all the nitty-gritty areas ready for the finishing.
And these are new strategies. I mean, 30 years ago you would have just really had a shortest path slot milling strategy, which still has its place definitely when you're using maybe older machines and they can't run so quick. But the new method of doing fast and light cuts, whether those be low depths of cut with a high feed cutter or low widths of cut with a trochoidal, those are fantastic, because you're taking those small light cuts, you're taking them quickly, they're much easier on your machine, much easier on your tool, and you can still rip out the material a similar kind of metal removal rate.
Yeah, absolutely. It's all about keeping that metal removal rate, and that's where the trochoidal kicks in. It's adapting its feed rate per pass, per line, to maintain a metal removal rate. When you're coming into the tight little corners, you want that engagement increasing. That's going to put extra pressure on your tool. You want to start reducing that feed rate, slow it down a little bit in the corners. And
it's all about the wraparound in the corners and whatnot. But what I love is you could also, so hardened tool steels, really great for trochoidal and high feed, but also the F55 super duplex, the heat resistant super alloys, because you're taking those light cuts, you can still apply those same strategies to all these more difficult to cut materials.
Exactly, yeah. And these are tick box exercises for us. That our cycles are so well developed, you just turn it on and away you go.
It's almost like you don't really care about the material. Obviously it'll change the feeds and speeds, the kind of cutters, but actually the cam strategies don't change all that much.
No, absolutely. We've got a couple of roughing cycles. It's all we need for the vast majority of components that you'd ever require in the hard material range.
Okay, so we've talked about roughing. Let's move into the finishing. Now get a look at these. Now there's beautiful blends in these corners, Josh. I've got absolutely no idea how you do this, because I was just imagining you've got these flat faces which are flat to axis, which I guess you'd machine straight with an end mill. But as soon as you've got anything with a slight angle on it, you've got to start scanning it out. There's completely different approaches to what, to some layman, which I put myself in that camp. To some layman would look, well, you do that surface the exact same way you do that surface, right? But you can't, because of maybe some weird little angle or some weird little radius on it. How do you achieve these beautiful blends? Look at that beautiful part.
Rowan, yeah, it's an exquisite part, beautiful. Machined in Germany, Fronten, and yeah, represents its own challenges. You know, a mixture of ball nosing and the hypermill open mind innovation, the conical barrel tool. So the conical barrel tool is typically used on all the flat areas for an efficiency and good surface quality.
Yeah, I can see actually the barrel milling. Sorry, I've just touched it there. The barrel milling. You want to make sure you can show this part off to as many people as you can before it starts going rusty with people like me touching it. But I can see the barrel milling step downs here, and barrel milling is about having. Can you explain how barrel milling works, please, Josh?
Yeah, by having a large contact radius for the surface, you can achieve massive step downs compared to the conventional ball nose. There's other benefits as well, you know, in the geometry of the tool, whereby you increase tool rigidity, and because it's got a small ball on the end, you can build this up from a 3mm ball on the end up to a 12mm shank, 16mm shank, so you can really rigidity built into that tool and setup. So therefore, surface quality and tool life also increase at the same time.
They're a really fascinating geometry, actually, because as you mentioned, they've got that little 3mm ball nose or 4mm ball nose on the end, so you can actually finish a big fat wall with massive step downs. But then, if you've got the right radius for the bottom of the pocket, you can then go and whip round the bottom of the pocket radius in like an aerostructure part that has a 3mm radius on the bottom specified.
Yeah, absolutely. You know, and by using the same tool, utilising the same tool in all of the rest material areas, you get perfect blending.
But you don't get perfect blending, obviously, if you just get your materials from any supplier. What you need to make sure is the materials are homogeneous. You need to make sure it's accredited. So you know that the strategies you employ, the cutting tools, and the cutting feeds and speed you employ, they're going to work on that material because it's accredited. It is what you know it's going to be. That's why you need to check out Intoco for all your special steels and alloys, for your F55 super duplexes, for all your tool steels, to make sure that when you use fantastic technology like Hypermill, like our cutting tool partners, your cutting tool partners, and you employ those right feeds and speeds, you know that the material is going to be right, so you can make a good part and make it quick and efficiently. Right, let's keep moving on, Josh. Can you explain to me what this part is, please?
Yep, so I'll just swap sides. So this is an engine turbine ring. This was manufactured on a simultaneous mill turn machine. And, you know, the challenges here, again, with the hard material is we're now having to actually adopt turning into the scenario. And we've got a very special solution for that with our tricoidal turning package from Volumil. We do things slightly differently compared to the traditional tricoidal for turning. And we actually do a ramping cut, which increases the cut and decreases the cut as you're going through. Changes the cut point on the tool, you can start to increase your speeds and feeds even further compared to the...
It's fascinating. There's 2 points that are fascinating to me about this. It's partly that you've obviously been developing your tricoidal, your Hypermax volume mill machining, which I've used personally. It's all about the lead-in, it's all about the line-by-line feed rate changes in the corners, all that good stuff. But you can apply that exact same idea, which is kind of in a 3-axis, you kind of go like that, to a 2-axis lathe. So it's the exact same toolpath, but you just kind of flip it on its head. It goes down in the X and the diameter and the Z.
You've got all the benefits as well, you know, in comparison to the milling. You know, we're controlling the feed rate, adapting the feed rate into the corners. Yeah. It's a superb solution.
It's a shame you don't show, I mean, this is a beautifully finished part, but it's a shame you don't actually show the results of the roughing operations. All you see here is the finishing. So those roughing operations might only take, I don't know, 10, 15, maybe 20, 30 minutes of the total part time. But what we're seeing here is the whole, I don't know, this maybe 12 hours worth of finishing that's gone into it. It'd be nice to see actually a stage by stage breakdown. Maybe you could sort that out for the next match.
Video going for you guys, no problem.
Yeah, definitely. So this is again a beautiful part. This is a tool steel again, I think. So they've got the materials in a German standard that I'm afraid I don't know my materials that well.
It's a tool steel.
It's a hardened tool steel, and again the tricoidal milling. It's funny how, but these engine turbine rings or engine casings, these are parts that have been made for 30, 40 years. So it's the same kind of form, it's the same kind of part, it's almost probably the same kind of material. Maybe they've improved in homogeneity or some parameter over the years, but you're using completely different modern ways of making them, completely different operations, which is great how the parts don't change, but the processes and the ways you make them do, and obviously the cycle times will be heavily reduced.
Hey, look, with the material advancements, the cycle and the machines and the tooling, everything that goes into these has to move forward for better efficiency and better quality. And it's cycles for us like the shape offset roughing, which allows us to use 5-axis trochoidal machining, to machine these dome faces. That actually mentioned about the roughing. Yeah, it's the perfect solution. You're getting near net shape on almost freeform surfaces from a roughing scenario,
which you never normally get. You normally get really awkward, weird steps going down, but because your tool can rough, I mean, I think I've actually used that to machine the base of like a blisk, yeah, or your straight blisk. You use the bottom because you're following that bottom curvature, and it's just taken out all those semi-finishing operations just to get from the roughing horrible steps that are left to the lovely last little 1 mil off the surface ball nose finishing. And you guys are, every time I come to one of your stands or see one of your videos, you've always got a beautiful part to show off. You had the crown, you had the panther, you got the stiletto, yeah. Everyone loved the helmet. Obviously, who could forget the helmet? But I've got to say, this is probably my favourite. The hardened tool steels. I'd love to see you make nice parts in aluminium, but hardened tool steels, you can't get much better than that. Next time, you're going to try and make something in maybe F55 Super Duplex from Intoco.
Give it to us. We'll do it.
Okay, maybe Les can sort that out. Maybe you can send a little bit of material over to Hypermill. They can show it off. But that's it. I've learned so much today about tool steels, about cam strategies. Thank you very much, Josh.
Thank you, Brian. Take care.
Well, I'm here with David Welsher of ZCC Cutting Tools, and we're going to be talking about this component. But before we do, F55 duplex. Essentially, what's the difference between duplex and super duplex?
So duplex materials are 50% authentic, 50% frenetic. Super duplex, then we've got an added element of chrome and molybdenum.
And what's that mean to the machining process?
The machining process and the yield of the material is higher. So for the first part, we need to machine wet to avoid build-up edge, and the material work hardens the longer in cut.
And this has been supplied by Intoco Special Steels and Alloys, and yes. I know you've got a decent relationship in there.
Yeah, definitely. We've done a project with MTD at Intoco on heat-resistant super alloys and advanced techniques for turning in difficult materials.
Okay, so if we're talking F55 Super Duplex on this occasion, how would you recommend machining this? Maybe we'll have strategies for people with cam and a strategy for people without cam. Okay, so there's the two ways to attack this component. Without CAD, advanced CAD software, you would use a not traditional turning approach. You would use maybe a 75-degree approach, but due to the feature of this component, possibly a 45 with the biggest, thickest inserts you can possibly use, SNMG 19 maybe. And go up to the shoulder and just...
Yeah, we profile the shoulder as we are turning down. Machine stability is important on these materials. We need to have a strong and stable process. We need to have good coolant flow. Because of the work hardening, we need to remove this material as quick as possible in one hit. If the insert and the strategy fails, when we pick the job back up, the materials are hard. It's like glass, and then you have all sorts of insert and tooling problems. So the strategy is key. So we try to take as deep as depth of cut as possible, profile in down to just above the finished dimensions, and then possibly run a button tool across the profile to give you a nice surface finish.
And that's what has been done traditionally, certainly in Scotland, big heavy-duty
oil
and gas industry. But it's fair to say, with the advances of CAN systems, there's other ways of doing it now. In fact, we did an Intoco on that video, but for the people that didn't see it, let's talk about that strategy again.
Yeah, at Intoco on the Inconel 718 component, we introduced Intoco customers to what we call trochoidal turning. Different CAD suites call it different names, but trochoidal turning using a large diameter button tool, travelling across the surface with lower depths of cut but an higher feed rate, traditionally higher surface speeds than you would with traditional insert methods. it's kind of on the machine, it's kind of on the inserts, but most importantly, it reduces cycle times by up to 50% on these materials.
So I think most of the viewers have probably heard or even used trochoidal milling.
Yeah.
But for people who haven't done trochoidal turning, obviously the clue's in the name.
Yeah.
But just tell them about that process.
So trochoidal turning exactly the same as the milling. It's a three-dimensional tool path, a waveform tool path, and it's multi-directional. So we are in contact with the surface nearly 100% of the time. It's only when we are like a figure of eight movement sometimes in the corners. So we always got a soft exit and entry of the material, which again enhances tool life.
Yeah, so in terms of machine technologies, are we talking about, is that a machine a limiting factor when you're doing trochoidal turning, or not really?
Not so much the machine, but the software. You need to have the software capabilities. Most software and machine control systems embed these functions into the systems now. The good thing about the trochoidal turning is it's not, you haven't got to buy additional tooling. It's standard traditional button technology, whether that's shank form 20mm buttons, for example, or whether we're using radius grooving inserts, depending on the dimensions of the part.
Yeah, and we're not talking about tree multitasking machines, are we? No. Although you could do a similar strategy using the B-axes.
Of course, yeah. The B-axes, the sort of multi-axes on the machine for the trochoidal is kind of on the tool paths are better. Mm-hmm. So the more advanced tooling you have, the more advanced CAM software, the more advanced trochoidal strategy and tool paths you can and shapes and process you can apply to the component.
And for the people watching this, if we go back to the we call it traditional strategies,
yes.
What sort of data are we talking about in terms of VC, feed rate, depth of cut, things like that?
So traditionally with super duplex, the tolerance on super duplex is a small band of tolerance, so you would normally 60 to 80 meters, 0.3 feed rate, maybe depending on the machine's stability is your depth of cut. On a large CNMG, you could take a 6-7 mil depth of cut quite comfortably at a 0.3 with a 60 to 80 meter surface speed. With the trochoidal strategy with a button, we up anywhere up to 160 meters of 1 mil with possibly a 2 mil depth of cut.
Yeah, no, for sure. And if we look at the actual surface finish, that's key, isn't it? So how do the two variables, how do the two different strategies affect the surface finish, if at all?
So the traditional methods, the roughing, you ain't going to get any surface finish at all. So you've got to bring a secondary tool into the process, whether that be a small diameter button tool travelling across the surface quickly, or a traditional positive insert to give at a slow feed rate, very time consuming. With a trochoidal strategy, you roughing and finishing in one process. So you'd be travelling across the surface at an higher feed rate. And you get because it's a round, not a sharp point. The quicker you travel across the surface, you can travel across the surface quicker to achieve a better finish.
And obviously, we went to Intoco. In fact, we've been there a number of times. Yes. They've got big, robust, heavy-duty, world-class technologies, haven't they? So, but for people that haven't, what would you say to those?
Before you start machining these materials, you've got to make sure you've got the right equipment, the right work holding, the stability. The advancement in technologies are clearly there to see, but you don't need to have them. For businesses that haven't got the capability of going out and buying a new machine, you can incorporate these new strategies, but you've just got to be careful with the data. The depth of cut is the key, really.
Yep. And that's pretty much covered the turning of this component. But I don't know if the camera can see it. We've got a milling feature on the side here.
Yeah.
So are we going to attack that? Maybe for people with cam.
Yeah.
And for people that don't have cam.
So on smaller components, if you look at the feature on the end, it's probably EDM. Mm-hmm. But for large components like this, where you want to finish a component in situ because of the weight and the logistic kit, with moving this part around the workshop, I would get a large indexable drill in there, just close to finished size. Obviously, just traditionally bore out the feature using an internal grooving bar, and then we would bring in the live spindle tool in and trochoidal or 3D mill the feature itself.
Okay, so let's just pretend I'm a new startup company. I've never machined this material before. Clearly, you need to speak to Intoco about learning about, educate yourself in the materials. Well, then what do we do from there? Going on forward from there.
If customers need to tackle these materials, it's always a good idea to get tooling manufacturers involved. We at ZTC are very capable and have a long history in machining difficult to machine materials, and we're always here to help apply these processes.
Yeah, and just for the people who aren't aware of your company and the different grades and technology you have, you've got, how do I put it? Do you call it hybrid technology in some of your inserts for these
materials? For
these types of challenging materials, maybe just you can briefly mention that.
Yeah, so our business, we spend a lot of money on R&D, put a lot of investment back into the technologies for heat-resistant super alloys and difficult to machine materials such as super duplex. So we've strayed away from the traditional technologies of cemented carbide. Yes, it's still cemented. New sintering techniques, new additives within the cement to make the product stronger, which enhances tool life.
There we are. Expert in cutting tools. Thank you very much, David.
Thank you, Joe.
So if you want to learn about these challenging materials, you should speak to Intoco without question. But if you want to machine these, perhaps you should speak to this man. Now over to Gio, who's got members of the Intoco team.
Wow. Open Mind have just put in a request for your material, and I'm sure Intoco Special Steels and Alloys will make that happen.
They certainly will.
Now, Ruth, we've had a great week so far, and we've still got one day to go. Intoco seem to be going from strength to strength. Can you give our audience a little bit of an overview of Intoco and who you are?
Yeah, well, Intoco, this is Intoco's 50th year. July, we've been going 50 years. We're now really well known as one of European's largest distributor and stockholder for stainlesses and high nickel alloys. What can I say? Continual investments all throughout those decades have just improved our stature throughout the world. We've got our own network of deliveries for the UK, great connections for worldwide and European shipments as well. 22 grades of steels and nickel alloys, and we pride ourselves in stock and having a great range of stock and high value stock, great commitment from the management team, and we should basically have all the requirements that's needed from our customer base that we take care of.
We'll be coming back to that stock shortly, but you also pride yourselves on quality. I mean, this is something that's so important to Intoco. Talk us through the accreditations and the quality that goes behind supplying this material, because some people don't really appreciate this.
No, Intoco have a customer-focused quality management system which is accredited to ISO 9001, which was put in by the management team, and we pride ourselves on meeting our customers' needs from top to bottom. We work with the best mills in Europe, as Ruth has just mentioned, to give our customers everything that they need from one place.
That's really important. And I mean, you do go to the nth degree. We touched upon it in the opener, really. You know, you colour code all of the materials you supply, and this is unique to Intoco. Why do you do this?
Well, we do have a colour coding system which you can see here, and it gives the guys in the workshop a subliminal indicator of where we can find the correct materials at the time we need to pull the material off the shelf to supply the customer.
You don't only colour code the bar, but you also stamp the bar and you also deburr the bar. Now, you mentioned stock. How much stock do you hold at any given time?
Well, it can be anything, but around now we've got about £17 million worth of stock in speciality steels. What we made sure we did was to continually buy through the nickel alloys rising. We wanted to make sure we got continuity of supply to our customer base. We made orders where a lot of our competitors didn't, so we've got materials coming in throughout the coming months so we can supply our customers. We can be relied upon as a one-stop shop to our unique customer base.
Over £18 million worth of stock at any given time is just phenomenal. But in this current climate, when we're all suffering with material shortages and the prices of materials also going through the roof, this is just unbelievable, isn't it, Doug? How important is that to your clients to know that they're safe and they've got stock?
Well, as you just mentioned, we are well stocked with £18 million worth of material. The price of nickel is currently astronomical, so we've made sure that we have had the foresight to book the materials with long lead times prior to the mills ceasing to produce and deliver materials. So at the moment, if you want to come to Intoco for the materials, you can guarantee that we've got what we say.
And that is, again, so important. Now, it's not just about the materials, it's about the team at Intoco. And again, you're not just supplying materials, you've got a skilled team, such as yourselves, that know every single little thing about any given material. Again, how important is this?
Oh, it's so important. The knowledge at Intoco with the sales team is just phenomenal. There's decades and decades of years worth of experience. So we know what our customers need, we know how to solve their issues. We've got a technical manager that has produced amazing specifications to all the latest specs, looking at all the latest OEMs and all the latest NORSOC approvals. Our material is really top-notch quality, and what we can do is provide that service, provide those delivery requirements, just-in-time deliveries, and basically be that one-stop shop for our customer base. We really do care about our customers' requirements, and we show that by putting the money out there on our shop floor. Yeah.
So important, a company you can trust. Now we'll be going over to Lindsay now, just to close this show. But Ruth, Doug, thank you so much for your time. Thank you very much for supporting MTDCNC, not just this week, but for sponsoring us with Swarf and Chips, and also being on our MTDCNC channel. It means a lot. So
it really has been fantastic, and it's been a great week here at MACH. Great part of this excellent, show here this week.
Have you had a good show?
It's been amazing. We've made some really, really great connections, and just tied up with our connections that we've known a long time, just not been able to get out and see just recently.
Well, you haven't got no competition here, that's for sure.
No, not at all.
Over to Lindsay.
Yes, right, okay, so we've got this competition going. Voila. It just proves technology works, because I've had a message from Les. Thank you for messaging us, Les. And let me just tell you, so the stem was roughed out in the annealed condition, the hardened and double tempered to 46, 48 HRC, then finished machined, including the bayonet fitting on the front end, machined on a heavy duty Morosiki SL7. Now, if you are visiting MACH, come along, come and visit, because there's a competition on this. If you can guess the weight of this in kilograms, you can win that weight. That in pounds, can't you?
Yeah. Real money.
So that's not bad. That's not bad. It's been a really popular competition. So all in all, Gio, what have you learned from today?
I think it's been such an educational show, as we've mentioned on the podcast every evening. Always. Lindsay, I'm learning a lot about materials, not just from Ruth, Doug, and James, but also from Rowan. And it's been great to see people that have been participating in this competition. They've been taking it so seriously. They've been looking at the component drawing, trying to work it out. They've even, I shouldn't be saying this, some people have even been trying to lift it. We haven't. We haven't kind of encouraged them to do so. But it's been a brilliant week, full of education, and I think that's ultimately what this show is about. It's educating and evolving and learning about new technology.
And Les has just written all of that out. That is the backup, that is the service, that's the education that goes through when you're working with a company like Intoco.
Just to confirm, it is live. We've had some. I know Les is overseas at the moment, but he's put in another message here, and he said we have to do this. Gio has got to wear an Intoco.
Oh, you are joking.
Sorry. It's the only way we could get it on his head. Right, thank you so much for watching. Like I said, make sure you're following Intoco Special Steels and Alloys. There's a question coming in. But and the reason being is follow them on LinkedIn as well. Really important. Like I said earlier, they've got flash sales that they often do. Follow them, because that's you can see the bar menu of materials that they have to offer, and I think that for me is just being able to have that in front of you. You look really, you look interesting. Are you trying to lift it above the cliff?
That's messed my hair up for the MTA do tonight, Les.
Yeah,
Thank you.
Sam, by the way, Samuel in Suffolk, just another question that's come in. Nickel is really hurting the market. Is there any idea when it will drop? I can't answer that question. Samuel in Suffolk, we can speak to the team members. We can find out as
But also contact Les on LinkedIn about this. This is a subject that's really close to Les's heart. The nickel prices are going through the roof daily. For most companies now, steel suppliers, they're giving a quote that only lasts for 24 hours due to the fluctuation in prices. So contact Les, he will definitely give you the very best advice.
And another reason to follow them as well, because they are putting daily posts out on prices, I've seen on the LinkedIn as well. So right, okay, we're going to end it there. Thank you so much for watching. It's always interactive, so do keep those messages in, because there's still ways of us being able to contact you back and ask those questions to the team members as well. We're still going to keep going with lives today. Where are we next? We're on Shunk, aren't we?
Shunk.
We're going to be talking workholding.
Workholding, and they've got some fantastic products, but some products that really lend themselves to automation too, that you wouldn't necessarily think of. So some real new innovations there. And we're also going to be going to Chester Machine Tools for the last live stream of the day.
There you go, have it. So keep in your mind Intoco, special steels and alloys, and we'll be back with you in probably just over an hour's time.